Hello! This vid is about half-lives, and we're going to define what a half-life is. We'll read some decay curves, which is pretty easy, and then we'll solve some radioactive decay problems that just have integral number of half-lives, and that's crazy easy. Let's say you look at any one atom. Let's say this is one atom, and it is unstable. If you watch one atom and try and predict exactly when it's going to decay, you can't do it, because decay is a random and somewhat spontaneous process, especially when you look at just one atom. And let's say that we try to look at two atoms. It's still be random and spontaneous, and you couldn't tell very much. But if you have any chunk of any substance, it's going to have a bazillion atoms in there. That's like a magic trick. And of these bazillion atoms, then you can make some predictions of what's going to decay. While you couldn't tell anything about a particular atom, you could tell that in this sample of a bazillion, some of these, a certain number will decay. And if you made a graph of the rate of decay versus time, then at a certain amount of time you could predict the decay rate would be this, and later on it'd be lower because there's less atoms left to decay, and then even lower, etc., and you get a shape that looks like this. And from mathematics you might have heard that this shape would be exponential. So let's learn what a half-life is. The simplest definition is this here. So an example, so write this down, but an example of this was, let's say you have 2 bazillion atoms, a sample of, let's say, uranium-235. That's what's in nuclear reactors. If you have 2 bazillion of them, the half-life is the time it takes for you to end up with only 1 bazillion of them. And it just so happens that the half-life, the time 1/2 for uranium not 234, 235 is 700 million years. It's a long time. For another famous nuclear substance, plutonium 239, that's much shorter. That's only 24,000 years. Another way of defining it is by the activity. If you're measuring its radioactivity, then after 1 half-life, that rate of decay will have been cut in half. The units that you would measure that with could be BQs or becquerels, or if you're a little bit more old school, you can use CI or curies. Quite often, the IB will ask you to look at a decay curve and say what the half-life is. That's awesome because it's incredibly easy, and even your goldfish could do this. So an example of how to do it. You look at the y-axis, and it could be something like the number of undecayed nuclei. Notice they've got times 10 to the 6th, so you should always be dealing with millions or billions of atoms. And then x-axis will be in time. You pick any number here. Let's say you want to start with 1200 times 10 to the 6th undecayed nuclei. Half-life is when half of them are left undecayed. So half of 1200 would be 600. Go to your point, and you look up the times. It's at about 3. This is at about 10.5. And you see how long time did this take. And that took about 7.5 days. That's it. That's your answer. If you want to check yourself, that's no problem. You could do it again at a different point. Let's say I want to look at 1,000. and see when that decays to half, which is 500, somewhere around here. You look at your times again. This is going to be something like 5. This is going to be something like 13. And that difference is going to be 8. Now that's not exactly the same, but it's close because you're just reading a graph, and so it's just an estimate. Now this could be number of decayed nuclei, or it could be the decay rate, or it could be what's known as the activity on this axis. Either way, you would do the problem the exact same way. A half-life word problem is also incredibly easy. If you take a minute and read this, see if you can solve it. Hopefully you did. Let's see what you do. You look at the activity, which is 2680 becquerels, and it says so many times later it has a later activity of this. Now they're always going to do things in nice integrals, at least on the standard level stuff. And so what you can do is you say that if it starts at 2680, when it goes through one half-life, it's going to be cut in half, and you're going to end up with 1340 becquerels. Then it's going to go through 2 half-lives. That's my little abbreviation. And that's going to go to 670 becquerels. And it's going to go through a 3rd half-life. And that's going to go to 335. And it's going to go to another one. That's going to go to about 168. What do you know? That activity is the same as this one. So it went through 1, 2, 3, 4 half-lives. And if it took 16 years, you know 16 years divided by 4 years per half-life, or divided by, let's just say divided by 4 half-lives, that's going to give you 4 years per half-life. And that is your answer. It's just that easy.